Hi, this is the physics department. Here you will study A-level physics and there's BTEC physics as well. My name's Richard and we also have Arthur who teaches A-level physics. Today we're going to talk about some of the courses that you do on the A-level physics course. They include traditional subjects from GCSE such as electricity, waves, nuclear physics, particle physics. We do mechanics. We do all the traditional subjects you get on GCSE. Well, you also get some brand new topics which go into more detail like fields, like astrophysics, and we go into a lot more detail with some of the subjects that you study from GCSE. An example of that today is what's called stationary waves, and that involves how waves interact with each other rather than just one wave like you would get at GCSE. So in A-level we're interested in more than one wave at the same time and the effects that that creates. The effect that we've got here on two of the instruments here that you see is what's called stationary waves, and this is where a reflected wave interacts with a wave that's going in the opposite direction. So for example, on your typical instrument such as the guitar, you have a string, and when you pluck the string, the wave will travel all the way down the part of the instrument here. It will then reflect backwards, but at the same time there is a wave going in that direction as well. So what you have are two waves at the same time. An instrument such as a guitar is designed so that the waves completely reinforce each other or completely cancel each other, and that creates an effect. So if I pluck the string here, you'll see that the string vibrates. The string is specially designed to be the correct length and the correct thickness to make sure that the waves completely reinforce. So each of the strings on here will produce a different sound. They will vibrate with a different frequency, and each frequency corresponds to a different sound that you hear. So you're familiar with this with musical instruments and also if people sing. And the idea is that each individual string will vibrate at a certain frequency. So a device such as this is at the correct length, and you can put your finger down in certain positions to get different notes, and the frequencies will change. The equipment on this side here shows exactly how that works. So when you're designing an instrument and say it has a string on it, the idea is that at the one end you are sending vibrations to the string. So the idea at that end is that the string is being forced to vibrate up and down. So by going up and down, it is sending a wave all the way down the string until it hits this point here. At this point here, the string will then reflect the wave all the way back. Now what we're interested in is finding the frequency where the two waves match up, so that the wave going this way and the wave going back match up so that they create spaces where they totally reinforce or that they totally cancel. And that is where we create different patterns. So the simplest pattern is where simply the string just vibrates up and down. So the effect you get is that the 2 points here and here, the string will go up and the string will go down, the string will go up and the string will go down. And that's what we call the fundamental frequency. So when you pluck the string on the guitar, that is what the string is doing. It's just vibrating up and down, and you choose the length and you choose the thickness of the string so that it will vibrate up and down perfectly. And the machine over here will change the frequency. So that's what you do when you pluck the string of a guitar. If you put your finger on different places, you can force it in certain places to stop moving. And we have names for these things. The place where the string does not move at all, where it's got zero amplitude or minimum amplitude, they're called nodes. So they're the points where it does not move. And at the moment, you've got two nodes. You've got a position here where it does not move and a position at the end. The middle part is maximum. That's where the string is moving the most. So normally if you are plucking this string, you pluck it in the middle and you have maximum movement in the middle. You can of course create different sounds. You know, if you sing or if you whistle or you pluck a string, you can create different sounds, higher sounds and lower sounds. If we increase the frequency, so in other words, if we increase the number of times this wave is vibrating, then this time it goes faster. So the string will start going faster here, and then as a result, if you get the frequency just right, you'll see that now in the middle there is a position where the string does not move, and that's another node. So by changing the frequency of the waves, you change how fast they're going backwards and forwards, and now you create a position where right in the middle, that string does not move. You can actually put your finger on it and you would feel that it does not move. The two spaces in the middle are where you've got maximum amplitude. That would be a different note, and that is a note of twice the frequency. So that would have double the frequency, that's a new note. You can then increase it even further, where you increase the frequency more. You'll notice the pattern completely disappears, because as you go through the frequencies, it does not work, because they're not cancelling out exactly. But then when you get the frequency just right, you'll find that now in the middle, you've got two places where there is no movement at all, two nodes, and there are three places where you get maximum amplitude, and these are antinodes. So that is a brand new note, that's a brand new set of waves, that's a brand new, what we call a stationary wave. They're called stationary waves because the waves don't move. The energy is not being transferred across, it just stays where it is. So these are called stationary waves. And you can keep doing this, you can keep increasing the frequency, and what you'll find is it drops to zero because the waves completely cancel out. But then when you find the next frequency, where it completely matches, you'll see we get the next effect. And you've got to get it just spot on, but you should see that when it just gets spot on, you'll get some more nodes, some more antinodes, and you get the different note. And roughly, the frequency gap is roughly the same. So in an ideal situation, what you would find is, roughly this one is set up at 12 Hertz, so your simple shape like that is at 12 Hertz, then the other one is doing 24 Hertz. I can't do 3 because my arms won't bend or anything, but you do the next one, you get 3, that's 3 times, the next one's 4, that's 4 times, and so on. And that's how they're set up, and that's how you create notes on instruments. So you can create them on strings by sending higher frequency vibrations, make it vibrate faster. When you get it just right, you create a different note, and you can see how they are notes because they just line up perfectly. And this is a topic that you do at A-level physics. It's also covered at the BTEC physics as well. And in the A-level physics, what you would do, you'd do an experiment, you would look at how the frequency affects how many of these patterns you get and how that links. The other thing you can do is there is a force attached to this piece of string here, and you can change the force that's attached, which is just like changing the tension in your guitar. So if you're a guitar player, you know that at the ends you've got the screws where you can tighten the string, and in the same way you can add more force, and that will change the note as well. It changes how it behaves. So one of the experiments they can do as well, and one of the calculations you do on your exam, is that you would talk about how by adding more or less force, how that affects how this behaves. So if you tighten it, you tighten the string, you make the waves go faster. If you loosen the string, you make it less tight, the waves will travel at a slower speed. And that changes the patterns that you see. So if you're an instrumental player, if you play things like a guitar or another stringed instrument, you know about that by twisting the screw on there, you change the tension, and that changes how these line up. In other words, you tune the instrument, what we call tuning the instrument. So you would tweak that to make sure that the note, when it does this pattern, is at exactly the correct frequency you want for playing the notes. So if we wanted this to, we can set this up, but if we change the tension, if we change the force acting on here, then this would happen at a higher or a lower frequency, and that's how you would tune instruments. So that is one of the topics that you would cover on A-level physics. You would do the calculations, you'd do the experiment, and you would be explaining how all this works. So that is just a short introduction into some of the stuff that we do at A-level physics. You can see how it expands from your GCSE knowledge of waves. We're interested in more than one wave at the same time and the effects that you get when you get more than one wave. So this is a wave and a reflective wave and the effects that you get from that situation. Thank you very much.